When building electronics by hand, we usually use through-hole components. These are relatively large and easy to handle. But when a machine builds electronics, it uses surface mount components. At first glance, these may seem a bit unmanageable to the human hand, but with a little patience and magnification, you too can work like a machine. SMD, or surface mount devices, can be a bit tricky to solder, but doing so will allow you to use a lot of technology that's not available in through-hole packages. You can also save quite a bit of space on board design. So the most obvious variable we're dealing with here is size. Common passive components like resistors and capacitors come in a range of sizes from the relatively large 1206 spec on down to the blink and you might miss it 0402 size, and even smaller. Surface mount ICs come in a variety of packages, like this here SOIC chip, or this QFP chip, or even this little SOT transistor. These all have protruding leads, but you'll also find IC packages which only expose flat contacts, like this QFN chip. These can actually be a bit easier to handle as they have no pins to bend accidentally. So how do we get these little things soldered securely to a PCB? Well, first we need the right tools for the job. A good iron with a fine point tip and a sponge or mesh for cleaning it. Fine point tweezers, I like to have both angled and straight variants. A magnifier loop or a visor. Solder wick, solder sucker, and of course, solder. Thin solder with a 0.02 inch diameter is preferable. I find most PCB vices a bit too shaky and unstable for SMD soldering. So to keep my board in place while working, I can use some painter's tape to secure it to the tabletop. We'll start with the smallest parts and work our way up. So resistors come first. To secure the part to the board, I'll first tin one pad and using tweezers, gently slide the resistor into place and tack it down. Now I can solder the remaining pad and then secure that first one with a bit more solder as needed. I'll use this same basic process for the rest of my two-terminal components. When soldering ICs with many small pins, alignment is crucial. First, get the basic orientation of the IC using the indicator dot on top. Then, anchor the first pin to the board with just a little bit of solder. Now I can easily make fine adjustments to the chip's position while re-wetting that anchor point. And once it's nicely squared up, I'll solder the pin diagonally opposite that first one to finalize the position. For the remaining pins, your first instinct may be to avoid bridging. That's a good instinct, but we'll start by doing exactly that. By gently dragging the iron and soldering all the way across. Because the board is coated with solder mask, we can easily remove the excess solder. I like to use a solder sucker for this. Just prime the pump, heat the solder, and remove. Voila. But you could also use thin solder wick. Just lay the wick across the pins and heat it with the side of the iron tip until all of the excess is pulled off of the board. Once all the pins are cleaned up, I can check for any tiny remaining bridges using my magnifier. The same strategy applies to chips with pins on all 4 sides. Just be sure to pay close attention to pin-to-pad alignment on all 4 of those sides. Soldering a chip with no protruding leads may seem a bit daunting at first, but again, the same basic approach applies here. The main difference is that anchoring that first pin may be a bit more challenging. Once those smaller components are finished, soldering the larger parts like jacks and switches is a relative walk in the park. Okay, everything appears to be in order on my handmade Metro here. Now I'll just apply power and see that it does in fact work, as expected. I'm not surprised. I don't make mistakes. After you get accustomed to the scale of surface mount soldering, the process is pretty straightforward. Just be sure to use the right tools, a steady hand, and have patience. It's actually quite relaxing.